Hello everyone, today is September 19th, 2022, and today's problem is insert sort list. Given the head of a singly list, a linked list, sort the list using insertion sort, and return the sorted list head. The steps of insertion sort algorithm. Number one, insertion sort iterates, consuming one input element each repetition and growing a sorted output list. Number two, at each iteration, insertion sort removes one element from the input data, finds the location it belongs within the sorted list, and inserts it there. Number three, it repeats until no input elements remain. The following is a graphical example of the insertion sort algorithm. The partially sorted list black initially contains only the first element in the list. One element red is removed from the input data and inserted in the place into the sorted list with each iteration. Okay, example will be the input on the first row, second row is the output as we are understanding. And that's the one. Constraints. The numbers of the nodes in the list is in the range 1 to 5,000. The node value is from minus negative 5,000 to positive 5,000. Okay, the C language function is here. The struct list node, insertion sort list node with input at list node pointer. Okay, I will say something for the algorithm of insertion. Let me create a new image, discard this one. Okay, at the very beginning, the insertion sorted will do like this. 1, 3, 4, 5, 6, 2. Okay, so they will insert like this, and once, for example, the current pointer to 2, they will swap 6 and 2, like 2, 6 right here, and then after that they will swap this one and this one. No, that one. Yes, that one. So that will be 2, 5, 6. Okay. Original insert algorithm will swap every time. As the list example, so for the list node, we will search, for example, the new change will be for the number 2, if we will searching one by one and one until we found the one less or equal than this one. That's the new place, new positions. So we don't perform swap until we found exactly positions. Why I pointer this? Because in the Leetcode, the previous character here for this animation that shows me different action. They swapped multi times. For example, number 3, and they swap 7 and 3. That's okay. For the next items, they swap once and swap second time. That's because that's the static array. They have to swap one by one. But back to the linked list, that's much easier to do that. We just need to operate insert. Okay. Okay, back to the design. For the coding design, I'm thinking first one. Let me check. So for the linked, 1, 2, 3, 4. That's a good example here. I need the pointer 1. No, pointer 1 for the current one. I also need a pointer 2. For example, pointer 2 for the insert after. Okay, after insert right here for the insertion. Yep. I also keep the head as is for the return. Okay. That means I don't change the head. I just need the number 1 for the current searching, number 2 pointer for the point 1. I also need number 3 for, yes, I also need number 3. Okay, let me do one more thing. So that's not clear for the, it seems that I need at least 3 pointers. Let me do that again from scratch. 1, 2, 3, 4, 5, 6. Okay, so for example, we're searching right here P1, and we take this out. This new one for the insert, we call that P2. And we're searching around, we need the insert right here, so we need a pointer right here, P3. This still the head as until keep as is. Okay. That's the one. Back to the black. Okay, here to go. Yeah. So I need a 3 pointer. Okay, that's the P2. I just dropped out of the range, so you didn't see it. I marked P2 over here. 1, 2, 3. I need 3 pointers for the coding. Okay, back to the coding sections. I just copy that and back to my console to open the V and what's the insertion sort list. Insertion sort list dot C. Okay. Okay, I need an iteration way, so I need the first one. I need the struct list node P1 equals none. Another second one for the insertion element none. And I need a second one for the P insertion position. Okay, that's the one. Okay, for first one P1, I'm going to equals is next, while P1 is true, we do below, while P1 equals true, we just P insert element equals to P1 next. If P insertion position is true, we're doing below. We just set P. Oh, that's wrong one. I don't need a high case for the pointer. Okay. P1 is next equals P insertion, insert position, not position element next. Insert element equals next. Okay, for that one, okay, that's the case, and we need searching back. Searching back is not good. Oh. Okay. For the searching back, we have to searching from the head. From the head. From the head, we could searching like this. Okay. While okay, in that case, I'm going to set insert position initialize equals head. I'm searching from the head, and while P insertion positions next is true, and next value is less than P insert elements value, then we do below. We will do P insert position positions equals P insert position next. Okay, until we break. No, we need one more condition for that. We need P insert position next not equal P1. Okay, and P insert position's next value is less than else. While we found one, that means we found one, that means we just check if P insert position not equals the head, if equal the head, we just swap the head. Okay. I'm thinking if I need swap, I would redo the link, so we need to update the head to new node at Insertion node. Okay, that's the one. So okay. P Insertion next equals head next and head next. Okay. Okay, his next equals equals the head. Hold on, equals the head. No, let me see. So head, this one will equals the head. Yes, will equals the head. His next will equal the head. Yes. And the head. Hold on. So for the first one, yes, and the head will equals. Yeah, that's here. It is. The head will be updated. Okay, that's the one. Else else means we don't take care any else. So the p insert is element. No, that's element. That's wrong. Sorry, element. Element. Elements next equals p insert positions that equals next. We got it, that one. Hold on. We need P1. P1's next equals P insert element next to keep the link continue linked, and we update that one to the new position next, and the P insert next will be P insert element. Okay, that's the one. After that, we will quit. Okay, we will quit. That's okay. So we just return the head right here. Let me see. So in the top loop, there will be okay. There will be searching the input for the P1, and we just mark if this one is now not the end of a linked list. I will check it next to his element next. P1 next. Hold on. It will be 1, and P1 next equals the 1. Okay, I already got this before I start, so I don't need this one right here to keep the link not broken, and set the head and searching to the end. We got one. If there's no head, we just do update the head. After that, we just link the list to the current position next, and the current position next equals the link. Okay. Yeah, that's pretty much for that one. Let me see how we run that code. Time exceeded. That means that's not okay. First of all, while P is true, his next will be the P. Oh, okay, that's the wrong one. Yeah, that's the one. Okay. If the element is true, we just do the following stuff, all this stuff, and if the P1 next, insert next, P1 insert position the head, true. We didn't check. Okay, we didn't check the positions. Okay. Hold on. We also need check for the first one. We need check. No, we need to check first one. Positions value is less than P insert element. Okay, and if that's next and next, yes. So in that case, I don't check the next for his value. I will leave to the next iteration to check it. Okay, let me see. It's still not done. That means it's true is not equal to P, so the insertion equals, no, not equals insertion. Yes, insertion next. That's right, that's right. Okay. First one, I'm going to print out P1 value equals P1 value, and I'm also going to print out P position value always 2. Always 2, always 2. Okay, first one, the 2, fall 2. Okay, fall 2. So, if while P1 is 2, so insert, hold on. Oh, we didn't go. Okay, that's the one. P1 equals P1 next equals the 1. P1 2 1 4. Why that's always a 4? P1, let me see. P1 next. Okay. Oh, that's wrong. That's logic is the mask. So let me see. So we're using that one. That's the right one, right? That's P1. So we park in that lot. And how that P1 will back to the O. P1 next. And P insertion. That's insertion, right? Hold on. If that's the true list swap, and nobody changed the P1, right? P1 next equals no. We'll remove that one back here for his original one since we would handle the P1. So the P1 will equals his next, that's fine. And if that is true, we do below else. We already equals next. Yes. That will print this one, right? So the history is 214 and keeping on the 4. There's something wrong, so hold on. Something when they do swap, okay. They just swap one, hold on, okay. Yes. Okay, here the case. So when the P1 we found 1, so we just need to move P1 to the next as well. Let me see how we do that. So insert position equals head. Let me do this. Okay, so Yeah, I feel tired, so I'm going to debug this one next tomorrow. So today that will be all. Thank you for watching. See you.